Drop a like and do share. Leave your comments and do not forget to subscribe for more videos.
Hello everyone, thank you for watching Edupedia World videos. So continuing with the topic of ionic equilibrium, today we will look into the concept of acids and bases. Okay, so basically before we move on with the chapter, we need to understand what an acid is and what a base is. So the definition of acid and base is based on various concepts, and one by one we'll look into each one of them, okay, to get a better understanding of what these terms are. So there are three definitions to acid and base. Okay, so these are called three different concepts, namely Arrhenius, Bronsted-Lowry and Lewis concept. So these are the three concepts we'll study. Today we'll study Arrhenius concept of acid and base, and in the next video session we'll study the other two. Okay. So let's begin what Arrhenius concept of acid and base is. Okay, so before we go on with the Arrhenius concept, you might want to recall the concept you have studied in your earlier classes. Okay, when you were younger, you might have studied that base is something that turns red litmus blue and acid is something that turns blue litmus red. Okay, so that's the definition you have studied, but you don't have litmus, right? In exams, in your right now you don't have litmus paper with you. So what are you going to do is you're simply going to look at a molecule. Okay, you're simply going to look at its molecular formula, and based on that you should be able to decide whether it's an acid or base. Ultimately you will have to memorize most of the stuff, but based on some key concepts you will be able to devise a method to memorize that. Okay, so let's begin. Arrhenius concept of acid and base. So what does the Arrhenius concept tell us? Okay, so what does it tell us? So it's very simple, that any substance which can donate H positive ions, right? So H positive ions in their aqueous medium are said to be Arrhenius acid. Okay, this is the definition given by Arrhenius. He said that if you have any substance and if that substance can donate H positive in aqueous medium, that is when that substance is added to water, it separates out into H positive and something else, then it is called an acid or Arrhenius acid. For instance, HCl. So in its free form, that is pure HCl. Pure HCl doesn't remain in form of H positive and Cl minus. Okay, but as soon as I put HCl in water, okay, in pure water, when I put in HCl, okay, or maybe some other solvent similar to water, HCl will dissociate into H positive and what is left? Cl minus. Okay, so here I can see that the cation H positive is present and the anion Cl minus is coming from the rest of HCl. So since HCl has ability to donate H positive in water, it can be called as an acid. Likewise, we can have something else like HBr, okay, HF, they are all acids. HI, alright, H2SO4. So H2SO4 when put in water, it can again donate H positive, but this time H2SO4 has the ability to donate either one H positive, in which case the rest of the part remaining, that is the anionic part, alright, which is negatively charged, will be HSO4 negative, or it also has the ability to donate two H positives, in which case the rest of the part is SO4 2 minus. Alright, so this is the difference between what an acid is and what is not. Anything that can donate H positive ion, irrespective of how many H positive ions there are, okay, in an aqueous medium, is called an acid. Likewise, he also gave the definition for base: any substance which can donate OH minus ion. Alright, so H positive ion is sometimes also called proton. Alright, so because H positive ion, you might know that if you have studied atomic structure, H, that is hydrogen atom, contains only one electron and one proton. There is no neutron in it. So that means H positive ion contains only a proton, nothing else. So that's why H positive ion is also called a proton. So proton donors, okay, are acids, and OH minus is hydroxyl ion. So hydroxyl ion donors are bases. Alright, so for instance, if I have, let's say NaOH. So in pure form, okay, we don't care how NaOH behaves, but when present in water, that is in aqueous medium, okay, or some other solvent like water, when NaOH is present in that medium, okay, it dissociates into Na positive and OH minus. That is, it has the ability to furnish or to give or to donate OH minus ions. Hence, NaOH can be called as an acid. Similarly, I can have some other acids like calcium hydroxide, okay, COOH whole twice. So again here calcium hydroxide has the ability to either donate, okay, either donate 1H OH minus, okay, or it has the ability to donate 2 OH minus. But in either case it can donate OH minus when present in water, and hence this is also an example of a Arrhenius base. So that's it. Okay, that's the concept, Arrhenius concept of acid and base. So anything that donates a proton, that is H positive, okay, is an acid, and anything that donates hydroxyl ion, that is OH minus, is a base. Okay, so memorize this. Now, based on this concept of H positive and OH minus donors, okay, that is substances which can donate H plus and OH minus, acids and base can be classified into different types. Okay, they are namely, let's see. So acids are basically substances which can donate H positive. Alright, so these substances actually react with base. Okay, so acids are the ones reacting with base. So a substance like HCl, alright, a substance like HCl which can donate 1 H plus, or like HNO3 which can also donate 1 H plus, is called a monobasic acid. Is called monobasic acid. That is, they have the ability to donate 1 H plus, or in other words, they have the ability to react with 1 mole of base. Okay, 1 mole of this acid will react with 1 mole of base. So it is monobasic. It can neutralize 1 mole of base. Okay, there are other examples also of this kind, like HClO4, one of the strongest acid that there is. HClO4, HCl, HNO3, they are all, okay, pretty strong acids. So these are the examples of monobasic acids. Similarly, like I just showed you, that H2SO4 has the ability to donate 2H positive if it wants. Okay, so such kind of acids which can donate 2H positives, okay, or which can react with 1 mole of these acids can react with 2 moles of base, or they can neutralize 2 moles of NaOH, let's say, or 2 moles of OH minus. Such acids are called diabasic acid. Okay, so that's how it is said. Okay, acids are dibasic, monobasic, and similarly tribasic, and so on. Okay, another example of dibasic might be, say, H3PO3. Okay, so H3PO3, though it has 3 hydrogen, only 2 of them are acidic. That is, only 2 of them have the ability to come out in form of H positive ion. The last H doesn't have that ability, as it is not directly bonded with oxygen. Okay, so these are examples of dibasic acids. Likewise, you can also have tribasic acid. Okay, you can also have tribasic acids in your question. Okay, for instance, H3PO4. Okay, H3PO4 is an example of tribasic acid, also known as phosphoric acid. So this here in H3PO4, all the 3 hydrogens have the ability to come out in form of H positive when present in aqueous medium. So it is tribasic. Whereas in H3PO3, only 2 hydrogen have that ability. Okay, because the last hydrogen is not bonded with oxygen. Here all the 3 are bonded with 1 oxygen. So they all can come out in form of H positive. In the same way that we have monobasic acids, dibasic acids, and tribasics, we have, for bases, we have monoacidic base, diacidic base, and triacidic base. So let's see what they are. So an example of monoacidic base, okay, will be one which can donate 1 OH minus, or in other words, which can neutralize 1 H positive, 1 mole of H positive. For instance, KOH, NaOH, cesium hydroxide, rubidium hydroxide, all these are examples of, okay, monoacidic base. NH4OH, ammonium hydroxide, this is an example of monoacidic base. Likewise, we can have diacidic base, okay, bases which can react with 2 acids, or which can react with 2 moles of OH minus, H plus, are called diacidic base. Okay, these bases have the ability to donate 2 OH minus, like calcium hydroxide or barium hydroxide. Right. And then in the same way we have triacidic base. So triacidic bases will be like FeOH whole thrice. Okay, they can furnish 3 OH minus when present in water. Aluminium hydroxide, AlOH whole thrice. Okay, or they have the ability to react with 3 moles of H plus. 1 mole of these bases have these bases. Okay, or this base has the ability to react with 3 moles of H plus ions, and hence it is a triacidic base. Right. In the next session, we'll look at Bronsted-Lowry concept and Lewis concept of acid and base. Okay, once we are done with that, you can use any one of them to identify an acid or a base and solve your questions in the exams or anywhere else. So until next time, and once again, thank you for watching Edupedia World videos.